So I am on the assessment directions section, and you can see that there are two tests that you need to perform. One is to determine if the TIQ is lower than the industry average of 2.5 minutes or 150 seconds at the significance level of 0.05. So I took a sample data set right here, sample data set to show you. So you can see Q time is in column C for PT. So here I copied and pasted the question right on the Excel page, okay? So what you're trying to do, if the company should allocate more resources to improve its average time in queue, and you're going to test the PT protocol. So I have the data for PE and PT. So PE is a sample data set, okay? So for PE, I have from 28, cell 28, C28 to C52. So I calculated the parameter that you need to use. This is the average, the formula that I used, 28 to 52, C column. This is the standard deviation, 28 to 52, and this is the count, number of observations that you have. So I calculated this, and I'm going to use it for this formula. So let me delete those. Okay, so you're going to use the z-test formula, x bar minus mu. Oh, first of all, let's go to the hypothesis. So your first step is to set up the hypothesis. Your null hypothesis is Q time, average Q time is greater than 150, and alternate hypothesis is the average Q time is less than 150. This is what you are testing. This is what you are testing. So your test is going to be a left-sided test. So how do you determine this value? This is called critical value. You use the formula NORMSINV 0.05, left-sided test. And when you use this formula, you get the value negative 1.65, negative 1.65. So you're going to do the calculation based on your sample, So in step 3, you are going to do the calculation. So you can see 142.92 minus 150. 150 comes from here, 150. And they divided by standard deviation squared, which is variance. So this is the standard deviation, STD, and the square is this, divided by 25, And so that's how I put the numbers here. So now let me show you how I did my calculation. I have done the top part first. So what I did, I said equal to 142.92 minus 150. Enter. So I got negative 7.08, okay? So for the denominator, square root of this. So the formula is equal to SQRT, left parenthesis, and then standard deviation squared, this square. So I'm going to say 1.67, oh no, 167, sorry. 167.76 square divided by square, and then you can slash square divided by 25. $33.52. So let's do it separately, step by step, and then to make sure that calculation is absolutely correct. Okay, I'm going to do this first. Equal to 167.76 to the power 2. Okay, I got it. Now let's divide this by 25. I got this. Now take the square root, equal to SQRT square root of this number, the parentheses. So I got 33.52. The reason I did this step by step is sometimes Excel formulas are weird. They gives you wrong answers for some reason. Okay, anyway, now I'm going to do this divided by that. That is this divided by that. So I'm going to write down equal to this divided by that. Negative 2.11. Negative 2.11. Okay. Now remember, you are going to use your own data set. My data set is a sample data set, but your data set is going to be a larger data set. So these numbers are going to be different for you. And this number is also likely to be different for you. So this is what I get. Okay, now, what decision should I make? One important point you need to make is that is it on this side or on that side? Many students make a mistake. They say point -21 is on this side. It is not on this side. It is on this side. It is on this side. -21 is closer to 0 than -1.65. So when you observe your value on this side, you fail to reject the null hypothesis. In this case, calculated value is greater than this. So your conclusion is you fail to reject the null hypothesis. So when you fail to reject the null hypothesis, what does it mean? You fail to reject this. That means you accepted the average Q time is larger than 150. There is another place that the student makes mistake. So you need to be careful. When you fail to reject this, you are accepting the fact that perhaps your time in queue is longer. So now you're going to make the recommendation for the company accordingly. Okay? All right. Now, for the second question. For the second question, I'm going to the Excel page again, and I'm going to go up. Okay, now here is the question. Now they have a new protocol called PE. So now you're going to compare PE and PT. And you want to determine whether, no, this is question 1. Question 2 is here, that you are going to determine if the average service time in PE is lower than PT. So this is your alternate hypothesis. PE is less than PT, and null is PE is greater than PT. This is exactly. This is also a left tail test, and your graph remains the same. And this is your formula. Use this formula. Okay? So this is average of the PE. This is the sample average of PT, standard deviation, and so on. So I have done the calculations on this side. Okay? For PE, I've done now the D column because you're going to now work with service time. Service time is D3 to D27. Okay? So D3, I'm sorry, not D3. It is D3 for PE. Okay, gotcha. D3 for PE, and then D27. Let's double check. D3 to D27. Okay, you got it, D27. So D3 to D27. Now the standard deviation and the number of observations. And for PT, you're going to D28. For PT, you're going to do D28 to D52. D28 to 52. Average D28, 52. Number of observations 28 to 52. Now remember, your data set is much larger than 25. So I'm just giving you an example by using a sample data set. Okay, so going back, now I have these numbers. Okay, I have these numbers. How should I do the calculation? So let me show the calculations again. So PE, so I'm going to do the numerator, PE average, which is equal to D28, D3, okay. So PE average is in my calculation 90.88 minus PT average is 272.96 equal to this. Now let me show you the data set that I have done the calculation. Look, PE average is 90.88, PT is 272.96 for my sample. It's a weird number, but your sample will have definitely different numbers. Okay, so the difference is negative 182. Okay, and here is the formula. You can see 90.88 minus 272.96, 272.96. Okay, good. Now I'm going to look at the denominator, this plus this, S1 squared over S2 squared, and then I will take the square root. So the first is S1 squared equal to, let's say, S1 squared is 184 squared. So left parenthesis, 184.76 2 divided by 25. If I do it separately, I will come up with the same answer. Let me just show you this just for the demonstration to make sure that you're getting the right answer. Okay, equal to 184.76 square. Now this is equal to this divided by 25. If you want to do step by step, you can see 1365.49, same number. Okay. All right, now going back here, I'm going to add with this. Add this plus, I'm going to say 250.65 squared divided by 25. Oh, sorry, this is star. Okay, I'm going to make the correction. To the power 2 over 25. Right, 3878. Okay, this is a little tricky. So 3878. Now you're going to take the square root. I am going to take you there and then use the formula again. This formula I'm using. So the first one is equal to this minus of that, negative 182.8, which I got here originally, okay? And then the second part, I'm going to do before the square root, I'm going to do this square over n1 plus this square over n2. So I'm going to say equal to this square divided by 25 plus this square divided by 25. Enter. 3878.612. 3878.467. See, because I did not take all the decimals, when I did the cell reference, I get more accurate numbers. So either one. They are slightly different, but in this case, when I look at my formula, I truncate it in the sense that I use 1.8476, but there is more than that. 1.746, 36, 598, etc. I did not take care of those. But here, I took care of all of those because the cell reference. I referred to the cell, and the computer went there and read those cells and calculated those numbers. Now take the square root of this, equal to SQRT of that, 62.278. So if I do this one, I bet I'll get a very a number that is close to it. SQRT, parenthesis, right here, 62.277, right, you can see how close, 62.277 and 62.278, basically the same thing. So you got your numerator, you got your denominator. Now z is going to be equal to, numerator divided by the denominator. Enter. Negative 292. Now what is it? It's right here. Right? Negative 292 is on the left side. It's in the critical region. So you're going to reject the null hypothesis. So if you reject the null hypothesis, you are favoring the alternate hypothesis. PE is less than PT. Okay? If that is the case, then what are you going to do? You're going to reject the null hypothesis. Now, in this case, actually, critical region is negative 1.65. Negative 1.65. 1.65. Okay? Okay, you're going to reject the null if the calculated value is less than 1.65, and it is less than 1.65. So you're going to reject the null, and you're going to make the decision according to your finding. Okay. Now, I have shown you all the steps, and it took me less than 20 minutes. Now, remember, you do not need to produce another document. You can part 1 and part 2. You can just go to the Excel page and create another page, and you can just write your verbiages here in the text box. That will take care of it. Okay, in a text box, you can use the text box. You can use this, insert, and then what is the text box? Insert, and here, text box. And then you go to the Excel page, you're going to just create the text box, and you can just cut and paste, or you can type in here, or you can type your short report in Word and cut and paste here. In that case, everything is together, and it is much easier for you. Okay? So part 1 is here, part 2 is here. You are done. When you submit, just submit 1 page and you are done with it. Okay? Please let me know if you have any questions. Okay? I hope you find it helpful. Thank you very much. Bye.